Hello everyone. Today we are going to discuss the Orgel diagram for D2, D3, D7 and D8 configuration. But first of all, let us consider D2 case because that is the simplest case. So now in D2 case, or we can say D2 configuration, there are two electrons in the d orbital. If we have free metal ion, in free metal ion, plus 2, plus 1, 0, minus 1, minus 2, and there are two electrons. So when there are two electrons, the L comes out to be plus 2 and plus 1, that is 3. L is 3. And what is the value of S? That is 2 into 1 by 2, that is 1. S is 1 and L is 3. And if L is 0, 1, 2, 3, 4, it is S, P, D, F, G terms. These are the terms given. Okay. And term symbol is, it is L, 2S plus 1, J. But J is not considered here, but 2S plus 1 and L. These are the values we have to consider. So 2S plus 1, it comes out to be 3. So L is 3. So L3 means F. So 3F is ground state or D2 configuration. And if we go in detail, its total terms are 3F, 3P, 1G, 1D and 1S. These are the terms of D2 configuration. But when we talk about Orgel diagram is for high spin complexes. It gives us the qualitative description of the effect of ligand field on the energy of the states. At the same time, it also talks about the spin allowed transitions, because spin forbidden transitions, their intensity is very low. For example, 3F to 1G, 1D, 1S, that is not allowed, because for spin allowed transition, delta S should be 0, means they should have same multiplicity. So that's why we consider only 3F and 3P states. The P state does not split in octahedral field. First of all, we talk about octahedral field, then we go to the tetrahedral field, and then we extend this for D3, D7, D8. Now, P state, so P state in ligand field, see this is in free ion, and that free state that turns into T1G in the ligand field, and we will see the effect of ligand field on the energy of this T1G state. Okay, but F state that split into T1G, T2G and A2G in ligand field. So let us see the energy level diagram of D2 configuration. There is 3F and 3P. So for 3P state, it turns into T1G in the ligand field, and 3F state that split into T1G, T2G and A2G. So T1G, T2G and A2G. It is like this. Okay, so that is for D2 configuration. Now, if you see the D2 configuration, see in octahedral field, T2G is at the lower end and EG at higher energy, that we have already discussed, that in octahedral field, when we talk about crystal field theory, the orbitals whose lobes are on the axis, they are repelled more, because in octahedral arrangement, ligands are on the axis. Ligands are on the axis. So this is Z axis, this is X axis, and this is Y axis. So in this way, there are two electrons. Now it is like two electrons, and that will be transferred to EG with the same spin. T2G to EG. So it in ground state it is T2G2. In first excited state it is T2G1 EG1, and then it is T2G0 and EG2, right? These are the excited states. But when you say this T2G to EG, there are two types of descriptions. Say in T2G, it is dxy, dyz, and dzx. And in EG, you have dx square minus y square and dz square. So if we have one electron in dxy, other electron in dyz or dzx, right? So if this electron is excited to dz square, then it is of somewhat lower energy. See, dxy1 and dz square 1y, because electrons are delocalized in all the axes, x, y, and z all are involved. But if electron is excited to dx square minus y square, then it is only in the xy plane. So energy of this configuration is more than this one. Keep in mind. So that means there are four energy levels. Okay, first one is simple T2G2. Then in T2G1 EG1 there are two states, dxy1 dz square 1 and dxy1 dx square minus y square 1. There are two energy levels this and then next. So there are total four energy levels as per the observation. But here we are talking about 3f and 3p state. So it is nu 1, nu 2 and nu 3. Now if we have D8, just look 1, 2, 3, 4, 5, 6, 7 and 8. D8 configuration, T2G6 and AG2. So it seems like if one electron transferred without changing the spin, if one electron transferred to EG, it looks like there is transfer of one hole. So there are two holes are transferred from EG to T2G. See that electron hole formalism. T2 is two electron transfer from T2G to EG, but in D8 there are two hole transfer from EG to T2G. Write the Orgel diagram for this. This is Orgel diagram for T2. Now this one we are going to draw the Orgel diagram for T8. So it is like, say in this case A2G is of higher energy, but here it becomes inverse. A2G is at lower level, then it is T2G, and maximum energy is of T1G. But above this, there is 3P, T1GP. And now we are writing T1G of F state. That's why, T1G, T1G, same symmetry. So states with same symmetry cannot cross each other. Why? Because they interact with each other and therefore they bend. The lines bend like this. They cannot cross each other. They bend. Why they bend? Because states with same symmetry can interact with each other. That means their electrons repel each other and therefore they slightly bend. The state with higher energy, its energy increases, and state with the lower energy, its energy is lowered, gets lowered, it decreases. Why this is, and this is called non-crossing rule. Why they do not cross? Because if they cross, that means two electrons in the same atom with the same symmetry have same energy. That is not possible. That is impossible. That's why they will never cross each other. Did you get the idea of non-crossing rule? And why there is a bending? Bending is because the two states have same symmetry. Two electrons with same symmetry cannot have the same energy. Okay, you see the bending of these two lights. Okay, so we see D2 and D8. Now if we have D3 and D7, in case of D3 it is like this. So it is simply two hole transfer from EG to T2G. So D3 is its configuration, its state is similar to D8 because that is also two hole transfer from EG to T2G. So D3 is similar to D8 and D7. 1, 2, 3, 4, 5, 6, 7. So see, in this case even only two electrons can transfer without changing the spin, because if we see 1, 2 and 3, if they are promoted to EG, then their spin should be reversed, but only two electrons are there which can be transferred to EG without changing the spin. That means this is two electron promotion case. So this the two electron promotion case is similar to D2. So D2 is similar to D7 and D3 is similar to D8, except there are 4F and 4P state, rest is same. Only this spin multiplicity will change, and both they have 4F and P states. Remaining states are there, but they have different multiplicity. So we need only those states. We use only those states in Orgel diagram which have same multiplicity as that of the ground state. So keep in mind F state, if it is a ground state, F state is always accompanied with P state. So let us combine these diagrams now. Increasing ligand field strength, on the other side ligand field, increasing ligand field strength. We have 3F, 3P. So when we have E2 octahedral, let us write it F and P only, because we are going to include D2, D3, D7 and D8. Okay, so see, in D2 case, and here we write D8 octahedral. Okay, so D2 case, minimum energies of T1G, then it is T2G, and here it is A2G and T1G. See, T1G and A2G, they can cross each other, but if they are of same symmetry, then they are not able to cross. So see, T1G, now this T1G and this T1G will go like this, but it is T1G, this is also T1G, so they will not be able to cross each other. That's why what happened, there is bending. This higher energy will go up and lower energy will go down. T1GP, T1GF, if they come nearby, they will repel each other, they will interact strongly, and therefore there is a bending of lines. So A2G remains as such, T2G again same, but these two will bend. Even T1GF, T1GP, here they again there is some bending, but because they are of very large difference in energy, their interaction is very less. So this is Orgel diagram for D2 octahedral. This is for D8 octahedral. And you know, D2 octahedral is similar to D7 octahedral. Why is it so? Because there is only two electrons which can promote to Eg from T to G without changing the spin. You know, spin allowed transitions are allowed in Orgel diagram. So that's why we consider D2 and D7. Difference is in D2 there is 3F and 3P. In D7 there is 4F and 4P. Otherwise it is F state, other one is P state. Next, D8, two hole transfer from Eg to T to G. That's why it is inversed. And D8 is similar to D3 octahedral. Why is it so? Because that is again two hole transfer from Eg to T to G. See, two hole transfer from Eg to T to G, because one electron is transferred from T to G to Eg. It is similar that one hole is transferred from Eg to T to G, and then other two electrons from T to G to Eg and two hole from Eg to T to G. So it is two hole transfer from Eg to T to G. That's why it is similar to D8. So D3 and D8 octahedral, D2 and D7 octahedral. They are similar. They are also similar. Now let us focus on the tetrahedral. So already I have explained, but once again I will explain that in case of octahedral complex, ligands are on the axis. Ligands are on the axis. But in case of tetrahedral complex, ligands are in between the axis. Okay, this is octahedral case, and this one is tetrahedral. So that's why here splitting is like this, T2G and EG, because those lobes which are on the axis, they repel more. And you know, dx square minus y square and dz square, they are on the axis. That's why their energy is more. But in tetrahedral, it is other way around. Why? Because ligands are in between the axis. So d orbitals whose lobes are in between the axis, their energy increases. Their energy is more than those d orbitals whose lobes are on the axis. So here energy of T2 is more than E. Only G word is omitted because octahedral is spherically symmetrical. Sorry, octahedral field is directional. Only G sign is omitted in tetrahedral. It is T2 and E. But see, the energy order is reversed. That's why when we see here T2 octahedral, so it is similar to D8 tetrahedral. D7 octahedral similar to D3 tetrahedral. Now come this side. D8 octahedral, D8 octahedral, D2 tetrahedral, D3 octahedral, D7 tetrahedral. So this is the combined Orgel diagram for these D2, D3, D7, D8 in octahedral and tetrahedral fields. Only difference is that in tetrahedral case, the word is omitted. Erased. G for, you know, that is omitted. This is all about Orgel diagram. Thank you so much for watching this video. Do like, subscribe and share my channel. Bless you all. Happy learning. Jai Hind. Jai Bharat.